Good morning, students. Today we are going to discuss half wave rectifier. Rectifier means a device which converts alternating current into direct current. So if you observe the switchboard, inside of the switchboard you can find alternating current. And in the case of mobile charger, we use DC, direct current. So direct current is used to charge a mobile, and similarly in bed light lamps also we use direct current, DC. So how can you convert AC to DC? So inside of the switchboard you can find alternating current. If we want to charge a mobile, we need direct current. So how can we convert that alternating current into direct current to charge a mobile? So we need a rectifier. So that rectifier converts alternating current into direct current. So rectifier is a device which converts alternating current into direct current is called rectifier. So this is the representation of alternating current. So it consisting of positive and negative cycles, positive, negative, positive, negative. So this is a alternating current representation. And a straight line, this is the representation of direct current. So the conversion of AC to DC is called rectification, and the device which converts AC to DC is called rectifier. So we have two types of rectifiers. One is half wave rectifier and other one is full wave rectifier. Half wave rectifier means only half of the wave will be converted into DC, and full wave rectifier means entire wave will be converted into DC. So wave is nothing but the combination of positive cycle and negative cycle is called a wave. So in a half wave rectifier, only half of the wave will be converted into DC. So if you observe this diagram, so this is a positive cycle, negative cycle, positive cycle, negative cycle. So this is the alternating current. So in this alternating current, only positive cycles are converted into DC here. So your positive cycle is converted into DC. So there is no conversion of negative cycle, and again positive cycle is converted into DC, and again there is no conversion of negative cycles. So in a half wave rectifier, only positive cycles are converted into DC. That means only half of the input AC is converted into DC. So that's why it is called half wave rectifier. So today we are going to discuss that half wave rectifier. So rectifier is a device which converts alternating current into direct current. And half wave rectifier means, you can observe the diagram here. So this diagram represents the half wave rectifier diagram. Here instead of this dotted line you can find a transformer. So this dotted line region represents transformer. So that transformer consisting of two coils. One is called primary coil and other one is called secondary coil. So this is called primary circuit and this is called secondary circuit. And this is the input AC signal, input AC. So this AC is going to be converted into DC. So this is the input alternating current. So alternating current is connected to the primary coil. And in the secondary coil, this is the secondary coil. So this secondary coil is connected to diode. So this is the representation of a diode. So this one represents the p-type semiconductor and this line indicates the negative n-type semiconductor. So p-type, n-type, it is a semiconductor diode, and this is the load resistance. So input AC signal is connected to the primary circuit, and the output current, that is DC current, is taken across the load resistance. So this diagram represents the half wave rectifier diagram. And the working of this half wave rectifier is, if you observe the primary circuit, so this is the input AC signal and this is called primary coil. So input AC signal is represented like this. So positive cycle, negative cycle, positive cycle, negative cycle. So this is a alternating current, input current. And so this is the output current that is taken across the load resistance. Now observe here, in alternating current, first we start from the positive cycle. So for the positive cycle, this is the positive cycle. So for the positive cycle, the diode is in forward bias. For the positive half cycle of the AC, the diode is in forward bias. When the diode is in forward bias, current flows through the diode. So for half of the wave, that is for positive half cycle, the diode is in forward bias. Forward bias means the positive type P-type semiconductor is connected to the positive terminal of the battery, and N-type semiconductor is connected to the negative terminal of the battery. P to P, N to N. P-type is connected to positive terminal. N-type is connected to negative terminal. So here for positive half cycle, so this is P-type semiconductor and this is called N-type semiconductor. So for positive half cycle, the diode in the semiconductor diode, so P-type semiconductor is connected to the positive terminal. That means positive signal. So this one acts as a forward bias. So when the diode is in forward bias, current flows through the diode. So for positive half cycles, the diode is in forward bias. So the current flows through it. Therefore, only positive half cycle will be converted into DC. So that means that DC current is taken across the load resistance. Then immediately after positive cycle, which cycle comes? Negative cycle comes. So for a negative cycle, that means this one. This is a negative cycle. So for a negative cycle, the diode is in reverse bias. Reverse bias means in a semiconductor diode, P-type semiconductor is connected to the negative terminal of the battery and N-type semiconductor is connected to the positive terminal of the battery. That is called reverse bias. So in the case of negative cycle, your P-type semiconductor is connected to negative cycle. That means that is called reverse bias. When the semiconductor diode is in reverse bias, the current does not flow through the diode. So for negative cycle, there is no current through the diode. That's why output across the load resistance is 0. Next, immediately again positive cycle comes. And for positive cycle, the diode is in forward bias. Current flows through the diode. So we can get the output current across the load resistance, that is this one. That means for all positive half cycles, the diode is in forward bias. So when the diode is in forward bias, current flows through the diode. So in that case, all positive cycles will be converted into direct current. And for all negative cycles, the diode is in reverse bias. So when the diode is in reverse bias, current does not flow through the diode. So the output is 0. That means only for positive half cycles, the diode is in forward bias, and for negative cycles, the diode in reverse bias. So when the diode is in forward bias, then only current flows through the diode, and when the diode is in reverse bias, current does not flow through the diode. So in this way, for all positive cycles, the diode in forward bias, current flows through the diode and we can get the output across the load resistance. And for all negative cycles, the diode is in reverse bias, current does not flow through the diode, then the output across the load resistance is 0. So therefore, only half of the wave will be converted into DC. So that's why it is called a half wave rectifier. So you can observe the working here. For all the positive half cycles, diode D is in forward bias and current flows through it. And for all negative cycles, the diode D is in reverse bias and current does not flow through it. So only positive half cycles of input AC is rectified. So in this way, in a half wave rectifier, only half of the input signal will be converted into DC. That means only positive cycles are converted into DC. That's why it is called half wave rectifier. And the efficiency is defined as the ratio of output DC power to input AC power. Output DC power to input AC power is called efficiency. The ratio of output DC power to input AC power is called efficiency, and the formula for efficiency in the half wave rectifier is 0.406 RL by RL plus RF. So where RF is called forward bias resistance of diode, forward resistance of diode. So this is called efficiency formula. So in a half wave rectifier, the maximum efficiency is 40.6%. That means only 40.6% of the input AC is converted into DC in case of half wave rectifier. So this is our today's topic. Thank you.